Hi, welcome to my video presentation where I shall be explaining the work that I have done for the Sparks Foundation GRIP internship program in the domain of data science and business analytics. The task which I've chosen for the presentation here is task 6, which says prediction using decision tree algorithm. And the main requirements for this task is to create the decision tree classifier and visualize it graphically. And the main purpose is if we feed any new data to the classifier, it should be able to predict the right class accordingly. And the data set has been already provided to me. It is the standard Iris dataset that I have to work on, but do some in-depth analysis over that. So let's proceed with the Python notebook. So I have completed my implementation in Python language. I've used Google Collaboratory here. So and I have run this program on Google Chrome. So next is I shall be explaining the cells and my implementation here. So the first thing is like I'm loading the data set which has been provided to me by this link, as you can see here. And I have already transferred my dataset file to the Google Drive, and I mounted the drive here using these commands. And then after loading the file from the drive, I have imported the Python libraries. So the main Python libraries that I've used for my implementation is pandas, numpy, matplotlib, and seaborn. Mostly matplotlib and seaborn would be used for the graphical analysis, for visualizing the data decision tree, and for numerical analysis we shall be using pandas and numpy. So that's the basic functioning of the Python library here. And then we are loading the Iris dataset here, and then checking the top 10 records of the given dataset. So the first column is ID, the next column is sepal length in centimeters, then sepal width in centimeters, petal length in centimeters, and petal width in centimeter, and then we have the species. So out of these, this is the target variable species, and these are the input parameters. These four are the important input parameters: the sepal length, sepal width, petal length, petal width. ID is not that required. We will eliminate that later on. We'll see that. So next thing is basic information regarding the data. So you can see the basic information here, like what is the data type of the columns and all, and there is no null value, so the data is already clean because it's a standard data set. And we can have some statistical overview here in terms of mean, standard deviation, minimum, maximum, etc. And then there are 150 entries or rows in the data set. So 50 belongs to Iris setosa, 50 belongs to Iris versicolor, and the remaining 50 belongs to Iris virginica. Okay, so now we shall be visualizing the Iris data. Now we are beginning the mm, exploratory data analysis phase where we are visualizing the data set to some extent, and then we'll be moving on to development of the decision tree model. So as you can see here, I have tried to visualize the dataset features, and I have tried to find a pattern between the features of the dataset using some scatter plot here. So I have tried to find out the relationship between sepal length and sepal width here, as you can see. So if we try to see this scatter plots, we might predict that, or like we might come up with a trend line uh, going in between these two densities here. But I have not shown the trend line because that's not the primary goal of this implementation here. So moving on to the next one, let us use the Seaborn library to visualize the two features based on the target variable here. So again, we have used sepal length and sepal width here. So this is again a scatter plot, but this has been created using Seaborn library, and this has been created using the matplotlib. So you can see that there are differences between the graphs. Next, we create a pair plot, which gives us the relationship between all the features distribution with each other. So this pair plot consists of the scatter plots, then area or the density graphs, and then we could have also used histograms here, but area graphs are more trendy nowadays, so I'm using this. And here we will be able to find out the relationship between every other variable or the every other attribute which is present in the data set. And then we should also be exploring some new features. These new features are created by me in the implementation. These are not present in the data set. For example, sepal difference. So that will be the difference between the sepal length and the sepal width. And then we have petal difference that I have created. So that will be the difference between petal length and petal width. And similarly, I have created a new feature called as sepal petal length difference, which will be the difference between the lengths of the sepal and petal respectively, and similarly the difference between the width of the sepal and petal here. And again, two new features are created by me, and that includes sepal petal length width difference, and then sepal petal width length difference. So as you can see, the first one is the difference between the sepal length in centimeter and the petal width centimeter, and the next one is easy to understand. It's sepal width minus the petal length centimeter. So why am I doing all these things? Because I want to create some new features and would like to see which feature would give us the best result. Because at the end, we have to optimize the features. We need to look for those features which gives us the best results and which can help us to build our model properly and train it with the right data set. So feature classification is important, and in that process, we might have to create new features, and not just to rely on the features which are present in the data set. So now we can see that besides these four standard features which were already present in the data set, I have created remaining, 6 features here. So which you can see here, and their values are also shown, as you can see. Now, coming to the relationship between the new features based on class symbols that you can see. So based on the new features that I've created, I have tried to analyze the relationship between them using this pair plot. Okay. And then coming to building classification model based on the decision tree algorithm. So this is the main implementation which is required by this internship task. So I'll be coming to this now. I'll be importing the remaining libraries which are required. So that includes the tree from sklearn, then GraphViz. So GraphViz is an important library which is used for visualizing the decision tree in a graphical format, in an appealing format. And sklearn.tree is also used here for the decision tree classifier. And then we have sklearn model selection for splitting the data set into training and testing set. So we have imported the necessary libraries, and then importing the necessary library for GraphViz. Again, I should have included it here, but don't worry. So now what I'll be doing is I'll be separating the independent variables or the target variables from the Iris dataset. So I already told before that the target variable would be the species, because based on a given dataset or a new dataset, we have to identify which species it belongs to. So that's the main use of machine learning here. We have to predict based on the input data which species it belongs to. So that will be the target variable, and the independent variables are these, which is sepal length, sepal width, petal width, then the remaining 6 variables that I had created. But here I have just included 4 of them, because we just have to check which set of features gives us the best results. And based on my understanding and based on my trial and error, I found that these set of 8 features, where 4 standard features and 4 custom features gave the best results in my case. So that's why I'm considering these 8 features here in the X variable. So now before training the model, we have to split our data into actual train and actual test dataset for training and validating purpose. So we are creating the required variables here, X train, X test, then Y train, Y test here, and then we are using the train test split function. So the test size is 0.30, which means that like we are devoting the 70% of the data for training, and for testing we are devoting only 30% of the data. So the ratio between train size and the test size is 7:3, and the random state is 42. And then splitting the data into validation train and validation test. So again, we are creating the required variables here, and for this the test size is only 10%. So we are devoting or devoting the remaining 90% of the data for the training purpose. Okay, So this data is used for the validation purpose, and this data shall be used for uh, the modeling purpose, like before training the model. So that's the first thing that we have to understand. So, and then we have divided the data differently in both the scenarios. So before training the model, we are dividing the data in the ratio of 7:3. But after the model is built, for validation purposes, we are splitting the data in the ratio of 9:1. And that ratio is obviously train is to test. Okay. So next is now we create a decision tree classifier and train it with training data set here. So now this is the main function which actually builds the decision tree classifier. So I could have created a simple decision tree classifier without any parameter, but in order to be more specific, I have set the criterion to Gini index. Then minimum sample split should be equal to 2. So that is what I have included. So at least you would see that in this particular tree, you can see that uh, except for the leaves, uh, you can see that there are a minimum of two branches, or for every middle node of the tree, um, like there are two branches going on. So that is the main use of this minimum sample split is equal to 2. Then iris CLF is the iris classification variable which I have used to fit the required data. And then we will visualize the decision tree to understand it better. So this is the code for building this decision tree. And then you can see that it has been beautifully created here with all the necessary information provided, uh, including the set of the values, samples, and the Gini index included. Then the main function of the decision tree is to reach a decision based on the values inserted. So I think at the end, if you observe the leaf nodes, we are able to find out to which species the particular data belongs to. So if it lies in the third, I mean, there are three elements in this particular set. So each of those three elements refer to respective species. It could be Iris setosa, Iris versicolor, or Iris virginica. So the part of that element which doesn't have any non-zero value, so it indicates that species. So for example, if you consider this leaf, then 31 indicates that the data coming from this part must be belonging to Iris virginicum. So similarly, we can understand for the remaining leaves here. So that is how we like observe the main results of a decision tree. So decision tree gives us the results in mostly yes or no. If the classification has to be done in um, binary classification, or like if the target variable has just got two values, but uh, sometimes the target variable could have more than two values as well. And this was the case where we had target variable having more than two values. So coming to the validation part, we will be using cross-validation technique here. So cross-validation includes calculation of the accuracy. So as our model has been trained, now we can validate our decision tree using cross-validation method to get accuracy here. So the accuracy which was obtained was 88%, and then checking validation test data on our trained model and getting performance metrics. So here we have used sklearn metrics to calculate the value of y hat. Now, y hat, and here again you will see yt hat. These are all the standard ways of uh, denoting certain variables when it comes to uh, studying theoretical data analytics. We come across these variables, so I have named them accordingly. So the accuracy score for validation test data is 90%, which is a very good score. Then checking our model performance on actual unseen test data. So obviously, I would also have to uh, test my model on an unseen data in order to verify its uh, efficiency, because that was also a part of one of the internship implementation requirement that I have to test my decision tree model on a new data or unseen data. So that's what I'll be doing. I'm also trying to create a model for that. That model is already created, but showing the required validation here. So the score for that accuracy on totally unseen data is again 95%, which is better than what it was previously. So training model on the actual trained data. So as you can see, uh, I'm again training the model. So this is for the trained data. So I'm again using the function decision tree classifier, and then visualizing the final decision tree for deploying in real world cases. So again, I have drawn a new, I have actually implemented a new decision tree here. So this one is slightly bigger than the previous one because it has considered multiple cases, and uh, this is where we have actually tested our uh, training, like how well our model is trained to work for the real world case scenario. So that is what you can see here. And again, the criterion that was used for this decision tree was again Gini index, but there were other values which were also shown here. But there could be multiple criterions, but the default one is Gini. But I have clearly mentioned that here. There's no problem in that. Then checking the performance of model on actual test data. So this is where we'll be testing our model against the test data. So the model accuracy score on totally unseen data is again 95%. That is good. And then finally, we see that so far the accuracies were good. It was in the range of 90-95%. Now what we are trying to do is I'll be creating random test data points, okay, and I'll be seeing whether uh, my model is able to predict the species correctly or not. So based on so since as you can see here that in this x variable there were 8 elements or 8 features. So I have for every uh, row of this matrix, I have to include 8 elements or 8 features in every set. So I have randomly included that, and based on these data points which I have created randomly, I have tried to predict the species to which it might belong. Okay, so the first one, as per the model has predicted that this first one belongs to Iris versicolor. Similarly, the second one belongs to Iris versicolor. Third one also belongs to Iris versicolor. But this fourth one belongs to Iris setosa, and the remaining belongs to Iris versicolor only. Okay, yeah. So that was the end. I hope you enjoyed my presentation and you learned the basics of a decision tree and how it is used and how it can be implemented in Python. And thank you.